everybody. Thanks for joining us for this session on SharePoint 2013 Backup and Recovery with DPM 2012. What we're going to do is speak to you today about SharePoint Backup and Recovery, but primarily we're going to focus on DPM and how you can leverage DPM to your advantage with SharePoint to back up and restore its data. So before we dive into that, a little bit about who we are. My name's Chris Whitehead. I'm a Premier Field Engineer with Microsoft in the UK. We work on site with Microsoft customers, Premier customers, delivering proactive and reactive services, helping them maintain healthy environments. One of my responsibilities as the SharePoint EMEA Tech Lead was delivering Ignite training and preparing Ignite training, or helping on that with our engineers internally. And I've also been involved in the technical adoption program with one of my customers with SharePoint 2013.
Hi everyone, my name's Sam Hassani. I'm in the same team as Chris in the UK, working as a Premier Field Engineer. Although for the last 6 months or so, I've been working with customers on early adopter programs in the SharePoint beta support team. So to kick things off today, before we dive into the details of DPM and look at how DPM can complement native SharePoint backup options, we thought we'd take a moment just to have a look at SharePoint native backup and restore. And it's also worth pointing out now, really, that SharePoint 2013 doesn't really bring any major improvements to the table over what we had in SharePoint 2010 when it comes to backup and restore. Obviously, SharePoint 2010 offers some really, really cool capabilities. So let's take a look at what we have in SharePoint now as a whole. So really, this applies to both 2013 and 2010. So in SharePoint, it is possible to carry out backup and recover configuration settings in a farm. Obviously, we can't backup and restore our configuration database. This isn't supported. However, we can back up the settings and export these to a configuration settings XML file, and this file can also be used to reapply settings to a farm. With SharePoint, we can also back up and restore all of our service applications through central administration and PowerShell. It's also possible to recover most of our service applications using SQL database backups and restoring those. It's not supported for certain service applications, and for other service applications, such as search, there are certain pre- and post steps to be aware of. Obviously, it differs depending on the service application, but we do have that option too. So SharePoint 2010 introduced the unattached content database restore capability. So what this meant was if we wanted to recover content from a database, we could restore that database to a SQL server, but we didn't necessarily have to mount that database to our SharePoint farm. We didn't need to attach it. SharePoint could speak to that content database, retrieve an object, such as a site or a list that we need, export it out using the Content Migration API, and then re-import that package to the relevant place in our live production farm in the appropriate content database. We also introduced SQL snapshot support for the commandlets that we could use to back up and restore SharePoint. What this meant was, as we were carrying out a backup, for example, of a SharePoint site, we wouldn't need to lock that site. However, some of the limitations with the SharePoint native backup and restore capabilities that were present in 2010 and still here today in SharePoint 2013, there's no way to have automated inline item level recovery. So yes, we can use the unattached database recovery process to extract a list from a content database, for example, and retrieve a specific item by restoring that list to a location. However, it's still very much a manual process. And as we already touched on, it's not supported to back up and restore our configuration and central admin databases. Again, there is an exception to this if we have our farm in a stop state, so we stop all services, carry out the backup of the databases, and then restore those databases to a farm with exactly the same topology and server names and so on. So moving on to DPM and looking at what DPM offers, we'll be covering many of these capabilities throughout this session, and that kind of is the focus of our session here today. DPM does offer inline item level recovery for SharePoint, and we'll show you through that, and we'll be demoing that today. It does also support configuration central admin database restore, which we will refer to as full farm recovery, and the way that it carries this out is using the VSS writer technology, which we'll be talking through too. The way that it actually carries out backups and stores the backups and carries out its incremental backups, does mean that we potentially are using less storage for our backups too. So we'll be taking a look at that. DPM 2012 with SP1 does also allow us to back up to the cloud using the Windows Azure Online Backup service. So what this means is we can carry out all of our backups on-premise using DPM of our SharePoint environment, for example. We can then encrypt those backups and upload them to the cloud and keep our encryption key on-premise. So that data is secured and when it's hosted in the cloud using the Azure Online Backup service. We also have the ability to carry out role-based backup and restore and administration. So what this means is we could, for example, delegate the ability to our help desk or service desk to carry out SharePoint item level restores. And as Chris will talk about shortly, DPM, as it is part of our Microsoft stack, does offer protection for other Microsoft products, and we'll take a look at what those include. It's always been a little bit of a kind of common misconception that DPM doesn't support backing up and recovering service applications in DPM 2010. This isn't necessarily true. So we mentioned on the previous slide how we can use SharePoint to actually recover certain service applications using SQL database backups. We can definitely do this in DPM too. There may be a few extra pre- and post steps that we need to configure, but we can actually do this through DPM. I'll talk through that too.
Okay, guys, so we're just going to switch over to DPM in general at the moment and just spend a couple of minutes speaking about some of the general points around DPM, which products it can back up and restore, just for your reference, and also some scalability points. Now, this is like a kind of common marketing slide, so some of you may have seen this, but it's quite a good way of just showing what in the Microsoft stack DPM can protect. So there's a number of products, such as Exchange Server, SQL Server, SharePoint, and so on. And this is kind of a slightly old slide. There's some newer products in there, and obviously newer versions of these products will all be supported. Obviously, if we deploy DPM from a SharePoint perspective, we're going to get protection of SharePoint, but we also get the advantage that it's not SharePoint specific, so we can protect Exchange as well. So we can use it as our entire backup and recovery solution for our Microsoft products. Now, the way it works is we take what we call volume shadow copy snapshots, and we're going to look through the process of how that works throughout the session. And we can do those snapshots up to every 15 minutes. With SharePoint, it's actually every 30 minutes. And we send that data across to the DPM server. The DPM server will then actually store them in on disk-based backups, so online disk-based recoveries available. We can also do backup to tape, and we can do things like disk to tape as well. So we can pass them off from disk to tape after a certain amount of time for retention and archiving. Another thing that we can do, which is shown across on the far right of the slide, is we can actually protect one DPM server with another DPM server. So if we've got DPM in our local data center, we can use that to back up all of our Microsoft products in the entire stack. And then we can replicate that entire DPM server and all of its replica and recovery points to a DPM server outside of our data center. So DPM isn't for high availability. It is a backup and recovery tool, but you can kind of use it to your advantage to replicate all of the data once it's backed up from one location to another. So if your production environment data center were to fail, it's not there to fail over, but you could use it in the remote location to restore all those services and bring them back online. Just important to make sure that you don't confuse backup and recovery with high availability. They are obviously two completely different things. Of course, like Sam said, with Service Pack 1, we do add the ability to do cloud-based backups, which is kind of like an offshoot in here. We can go to disk and then up to the cloud. So a little bit about DPM scalability. Now, what this is really getting at here, we're saying that up to 100 DPM servers or 50,000 data sources can be centrally managed using the central management console. So one of the limitations in previous versions of DPM was that if you had 5, 10, 20 different DPM servers in your estate, you'd have to go and manage them all individually, which was quite a pain if you were managing terabytes of Exchange, SQL, and SharePoint data, for example. Well, now what you've got with the System Center suite is the ability to actually centrally manage all of these servers. And basically, the central management console has been tested to up to these number of servers and this number of data sources, which is quite extreme when you consider that each of these DPM servers could protect this amount of data. So one DPM server, for example, could protect up to either 100 production servers or 300 desktop or client machines. And what we mean by that is a production server would be something like a SQL Exchange SharePoint server, and the client machines may be desktops or laptops in the organization, where you're protecting the local files on those machines if you're not roaming or having network-type shares for users. 80 terabytes of Exchange data per DPM server. So again, 80 per DPM server. If you've got multiple Exchange instances or multiple installations, you can certainly have more DPM servers. And then up to 2,000 SQL Server databases have been tested per DPM server. There's nothing stopping you having more and more DPM servers and scaling this out. And then 25 terabytes worth of SharePoint data is kind of what the tested limit is per DPM server. So unless you've got a farm massively bigger than 25 terabytes, you should be absolutely fine to use DPM to protect that. So let's move on to looking at protecting SharePoint data and how that works.
So to start with, some of the configuration that we need to carry out. So at this point, assuming that you have DPM installed and configured, you've created your storage pool and configured disks within that storage pool, and we will show you what that looks like in the demo very shortly. The first thing you need to do is to install the DPM agent. So every server that we will be protecting with DPM will need to have the DPM agent installed on it. And this will be used to communicate between the DPM server and the servers we're protecting. And it will invoke the VSS writer, which Chris has already touched on and we'll be talking through shortly. So with the agent, once that is installed, we need to actually ensure that the VSS writer service is configured and associated with that DPM agent. So many of you who have installed SharePoint will see in your services console on that server that you have this WSS writer service. This is the SharePoint VSS write service. We can use a tool that's provided by the DPM agent to actually configure this. And this tool is called Configure SharePoint. It's part of the DPM agent install. We basically will run this, and it will allow us to set the credentials that are going to be used for the VSS writer. It's also worth mentioning that the DPM agent must be installed on every server we're going to be protecting. So from a SharePoint perspective, we install that DPM agent on a single SharePoint server. However, when we are protecting SharePoint, the VSS writer on that SharePoint server will actually invoke VSS writers on the SQL servers that are hosting our content databases. Consequently, we need to ensure that we have the DPM agent installed on those SQL servers that are hosting our SharePoint content databases too.
So when you think about it logically, when we're protecting a single SQL Server database somewhere, this agent is what's used for communications, so we'd have to have it on every SQL server that we're protecting. From a SharePoint perspective, the way we actually protect SharePoint is we do it via that single server that Sam mentioned. So we're not pulling all of the data through that server, we're just using that server to get the context of the farm, to figure out what the farm looks like, which other SQL servers or which other servers there are that contain our data. And since we all know that all of our data in SharePoint is in SQL, we just need to go to SQL and get that data. So that's why you have it on a single SharePoint server and all of your SQL servers that host your content.
So there's various deployment methods for that DPM agent, including DPM itself. You can push the agent out from DPM centrally to servers that you want to protect. It's just an MSI, so you could even install it manually. You could use SCCM or even AD to do that. So once we have our DPM agent installed, we've used the Configure SharePoint tool to actually associate the write service with the DPM agent on our SharePoint server. The next thing to do is to move over to DPM, and we create and configure what we call a protection group. So the protection group really is just a logical container for the data sources that we want to protect. We use this protection group to define things such as the backup schedule, the retention policies, and so on, and we'll show all of this in a demo very shortly. Because our demo environment is configured already, we're going to try and show you as much as we can and what makes sense given the time we have. We've just got a screenshot here of what the Configure SharePoint tool looks like. So as you can see, it's a command line-based tool. You run a single command, configure SharePoint, you specify that you're enabling SharePoint protection, and then you'll be prompted to enter the credentials that you want the WSS write service to run under. So when we're configuring our protection group in DPM, you'll be able to see a list of all the servers in your environment that have the DPM agent installed on it. And then within those data sources or servers, you'll be able to see that do have a VSS writer available. So in here, you should just be able to about see that we have a server called SP15RTM, which is our SharePoint server. And within that, you can see a SharePoint source. You can see that our farm is actually identified here by the name of our configuration database. However, with a single tick in this checkbox, we're actually protecting not only our configuration database, but our central admin content database and all of our other content databases in the farm.
And the reason for farm being in quotes here is because it isn't full farm protection in the sense of it isn't all the service applications as well. You need to basically manually go and tick them and add them as SQL data sources. So you can see it says SQL2 listed at the bottom there. If we were to expand that and click on the SQL Server instance, you would see a list of all the databases that were on that SQL Server instance. And Sam's going to show you this in the demo, but that would include all of those content databases listed on the right there. Now, if we tried to protect them as SQL sources again as well, we wouldn't be able to. You can only do one or the other. But once we selected them as a SharePoint data source, they are protected, but like kind of referentially from a SharePoint perspective. For service applications, we would have to then go and manually tick them. That's the kind of little caveat there with service applications. But again, like Sam said earlier, it's the same story you get with backup and restore with SQL Server. You just manually tick them, and when you want to do a restore of them, you select that one database you want to restore. And there's a little bit of extra work to do with hooking up proxies and so on that we'll speak for a little more later. So as you can see, DPM, when you tick that, will go and gather the data from all the data sources, and it will start protecting them. So let's have a look at the backup data flow. What happens when we do a backup with DPM and SharePoint specifically? So here we've got our DPM server with a bunch of disks attached to it and so on for our storage pool. And we've got a SharePoint farm with various SQL servers just to show you when it's scaled out in this way. Now, the reason why we've only got one SharePoint server shown here is because we only need to protect SharePoint with one server. We don't need to install the agent on every single server like we mentioned earlier. You can do if you want, which means you can quickly switch between them, but we're only ever communicating with one server when we start a backup or we initiate any restores. So what happens is the DPM server will go and speak to the SharePoint server via that agent. So it will use that agent, speak to the SharePoint server, and it will start a backup. It will say, I want to do a backup. That agent goes and basically invokes writers on all of the database servers. Now, again, the backups aren't happening through the SharePoint server. Technically, what's happening is the SharePoint server is telling DPM what other servers are in the farm, and then it's going to speak to the database servers. So the diagram doesn't really show it in the best way there. What then happens is the database servers, using their agents, will send the databases over to the DPM server, send the log files, and they're backed up. Okay? It's actually fairly simple. The final thing that happens, which is an extra step, is that because we can do item-level recovery with SharePoint, once we back these databases up, how does DPM really know what's going on inside? How does DPM know that we've got this list and this document within there? It doesn't actually go into the databases and start creating this magic tree for you, because it doesn't know anything about the SharePoint schema of the databases. What it does is it does this thing called, it creates a SharePoint catalog. And it will go and use the object model, the API for SharePoint, on the SharePoint server. So it goes and speaks to the SharePoint server and basically enumerates the entire farm and figures out what is in all those content databases. And it pulls that data back onto the DPM server into its own database. So when we go into the DPM console to do an item-level recovery, we've got a tree view and a searchable list of all the content in our farm. It's not querying the individual content databases that are being backed up. It's querying the live databases to find out what's going on, and it's cataloging that information for later restores. If that catalog job, for example, hadn't happened, you wouldn't be able to restore items. You'd only be able to restore databases. Now, if we were to add an additional SQL server into our farm, or just another database into our farm, what we would get is we'd obviously be in the position where we need to add that agent onto that server. Otherwise, we're not going to protect the data on that server. So the only additional step that you need to think about when adding new databases or new servers is making sure the agent is deployed. And you can obviously push this down, like Sam said, with SCCM and AD and so on. So you can ensure that it's on all of your servers. So what that looks like is we go and speak to the SharePoint server, figure out what the farm looks like. The SharePoint server will do the invoke of the VSS writers and speak to the SQL servers. And again, we'll be sending the databases back just like we did before. So we automatically protect new servers once the DPM agent's installed. And because we're getting the context of the farm from that SharePoint server, if we add databases to the farm or add them to additional SQL servers, as long as we've got the agent installed on those servers, we don't have to do any changes in DPM. We don't have to tell DPM that we need to do a backup of that database. If you're using SQL-based backup, of course, you need to go and tell your DBAs to back up that additional database, or you need to add it to the scripts or whatever you've got in place to do that.
Yeah. Obviously, adding a database to an existing server, in that scenario, there's no additional configuration that's required. It's purely, as Chris mentioned, adding an additional database server.
Okay. So then, same as before, catalog gets created. There's no difference, right? So we add a database, add a server, it's kind of automatic what's going on. So what we'll do is we'll switch over to a demo, and Sam will demo you the details on protecting SharePoint data with DPM.
Okay, so let's start by taking a look at the DPM Central Management Console. So as you can see here, we have various different ways to navigate around this. Currently, we're in management, where we can configure things such as the agents, the disks in the storage pool, even the online backup capability, if we were to use that. We also have other areas for reporting, protection and recovery, which we'll be diving into too, and monitoring, which can be very useful when we're trying to look at what jobs are running, why things might be going wrong. So starting with here in the management area, you can see within agents, which is where we are now, there's two servers that we have listed with the protection agent here. You can see that these servers are listed as unprotected because we don't actually have a protection group configured right now, but the agent is deployed and the status is set to OK. If we wanted to centrally deploy out agents to additional servers in our farm, we can very easily do that here from this wizard. We can either install agents directly, or if we've manually installed an agent on a DPM server, we'd need to use the attach option. So if I just quickly show you what it looks like if we were to install an agent, from this list here, I could select one of the servers that I've want to deploy the agent to. So you can see here, this is pulling through every server in my environment. I could select that a server, which doesn't have the agent installed in this case, so just select this server. It doesn't really matter which one I choose here. Go through the wizard, provide some credentials, very quickly do this. And you can see here, it's prompting me to choose my restart method. So as the detail says here in the dialog, the restart's only actually required if we're running on a server that is Windows Server 2003 or prior to that build. If we're running Windows Server 2008, which of course you will be for SharePoint 2013 servers, you wouldn't need to actually restart the server, so you could select the no option here, and the agent will be deployed without any server restart.
We'll speak about why that is in a minute, but basically because the DPM agent does some block level monitoring of changes on the disks, it needs to kind of insert that agent that it needs to have access to the blocks on the disk. And in previous builds of Windows, it wasn't able to do that without a restart. But we'll speak through the process and the way that works in a short while.
So if we move over to the disks area, here you can see that we have a DPM storage pool. Currently, there's one disk within this storage pool. And the way this works is you kind of just add disk to this, and DPM will manage how it actually stores its replica, how it uses the storage available to it to actually use a recovery area to actually recover data in addition to that. So if I just quickly show you the disk management console here on my server, you can see this disk 2 here has these DPM partitions created. One of these is where the DPM replica, which Chris will talk about, is stored. The other partition is used as the recovery area, which again we'll cover too. We also have an additional disk here, which is unallocated. It's 127 gig. It's not being used for anything. It's not formatted. It's just been presented to this server. There's nothing on it. If I was to add another disk to this storage pool, again, as long as the disk is in the way that I just showed you, we can simply select that, add it to the storage pool, hit OK, and it's then available for DPM to use as it wishes. So taking a look at the online area, because we don't have the Windows Azure Online Backup agent installed on this DPM server, there's nothing available to configure. But if you were to have that agent installed and you want to be able to send your backups to the cloud, you could configure that here.
And it is literally as simple as configuring your credentials for your online service. And then when you create a protection group, which Sam will show you in a minute, that's just an option in there to say, send the backup to the cloud once you've done the backup locally. You have to always do the backup locally first, and then it will send it to the cloud.
Okay. So if we move over to monitoring, before we go ahead and create that protection group, I'll just show you very quickly the kind of things that we do see here. You can see, if I expand this out, I can view all the jobs that have completed on this DPM server. So there's various different jobs, and you can see that we have different types of jobs being performed. So we have recovery points being created. So these really are our backups that are being created of the SharePoint environment. We have this catalog task job. So this is what Chris mentioned earlier, where DPM will create a catalog of content hierarchy of our SharePoint environment, and so on. So we'll show you how we can use this as well when we carry out a recovery later on. Okay, so let's move over to the protection area. So what you can see here is we actually have an inactive protection group created. So it's not actually a protection group that's created, but we have a replica that is available to be used in a protection group. So we pre-configured this to speed up the demo here. So we can actually use this replica with the new protection group that we'll now go ahead and create. So if I go and click on New just here, there's two kinds of protection groups that you can select from initially, either server or client. Chris mentioned how you could use DPM to protect your clients. Obviously, in this case, we're protecting a server. And now we can select the data source that we actually want to protect. So we're going to go into our SharePoint server here. It might just take a second to come through whilst our server wakes up. There we go. The server obviously already has DPM agent installed, which is why we can see it. We can then drill down into this, and you can see that we have our SharePoint farm available to us. And this is denoted by the configuration database name of my SharePoint farm.
And if Sam was to go and click on the SQL one right now, what you'll see is once it comes back, it will come back with an additional entry in there, one for SQL Server. And that's because it's using the agent to detect the SQL Server VSS writer, and that's returning the details of all of the databases on that server that can be protected. Now, if Sam were to go and try and protect a database that's been protected as a result of ticking the SharePoint box, DPM is going to say, you know what, sorry, you can't protect this twice, you can only protect it once. You're protecting it as part of a SharePoint farm protection, so you can't select it here, okay? If you were to click OK on that and go and protect a service application database, for example, that will be available for protection, and it will be added to the list of selected members on the side there. So we can basically add more than one data source, or more than one data source from multiple servers to a protection group. Protection group isn't really necessarily for one data source. It's actually for data sources that share the same SLA, for example. Protection group is about protecting data based on certain policies, certain timelines, how often you want to do backups. You really should tie it into your SLAs. There's nothing stopping you, though, creating as many protection groups as you want, but it is much more about SLAs and how you're managing your backups than it is about individual servers.
Okay, so once we've configured what our data source is going to be for this protection group, we have the ability to give it a name. We can select the protection method. So here, because we don't have a tape library or online option configured, we're just going to protect using disk. So it will use the disk pool that we've configured. Keep the default name there. We now have the ability to specify the retention range for the data that we're protecting. So how long we're actually going to keep this data for that we're backing up and protecting on disk. By default, select 5 days. I'll keep that set there. We also have the ability to configure the schedule of how frequently we're carrying out the express full backup. Again, Chris will talk about this in a bit more detail later on, but this really is just how frequently we're taking backups of our SharePoint server that we're protecting.
So Sam just zooms in on that so those of you at the back can see. You'll see that there are various options there. So we can say we're going to do an express full backup up to every 30 minutes is the absolute maximum we can do. And you can specify the days of the week that may occur depending on the SLA you have. So remember, DPM is about backup and restore. It's not about high availability, okay? So we're not doing continuous replication of data. That's HA. We're doing backups at a predefined schedule.
Okay, so we'll leave the default selected there, complete the wizard. We now have the ability to configure the consistency check options. So again, we'll cover this in more depth very, very shortly, but consistency check needs to be performed when the data replica that we're holding may become out of sync with our live production data. There's numerous reasons for that, and it will become more clear as we move through. But there's two options that you have here. You can either allow DPM to carry out this consistency check when it knows that it needs to, for example, following a server reboot, or you can actually schedule a consistency check to occur at a time of the day that may suit you better out of hours where you don't want any additional load on the DPM server, for example.
So again, if Sam just zooms in on those two options there so you can all see it, the options that you get really are automatically run this if it becomes inconsistent, or do it on a set schedule so that we don't have to worry about this too much in the background. Okay?
Oh, what's happened there?
Quickly run through the wizard again. I think it closed.
Did it close? That's not good. Just bear with us while we reselect that. I must have clicked on cancel. Keep everything the same as we go through this.
Everything that you can do in the DPM UI as well, you can actually do with PowerShell. So DPM was actually one of the earlier products to support PowerShell. So DPM 2010 had very good support for PowerShell. So everything from configuring all this stuff to actually doing restores can be done with PowerShell. So you can write scripts and do everything remotely with PowerShell remoting as well if you want to.
So before we go ahead and create the group, DPM will give us a quick summary of what we're doing, show us the data source and the group settings, so the retention range and the recovery point schedule. So we'll go ahead, create that group. So what DPM is telling us here is the changes to the protection group will initiate an immediate consistency check. So the reason it's firing this is because, as we mentioned at the start of this demo, we've already created that replica. So DPM now, as I create a new protection group, is actually going to reuse that replica. But before it can reuse that replica, it needs to make sure that we sync any changes that exist between this replica and our live set production data. Obviously, if you were creating a new protection group at this point, it wouldn't be carrying out a consistency check. It would just be doing that initial full sync.
What the replica is and how that works is going to become apparent in the next couple of slides.
Okay, so if we move over to the monitoring area, we just missed it. So we did see a job running there very quickly. If we have a look at completed jobs, and we sort by date, you can see here that
there's a consistency
check. And you can see there's multiple jobs there that all have type of consistency check. And on the left-hand side, you can see that these correspond to different content database, a configuration database, and central admin databases too. So it's performing that consistency check on each of those databases. Okay.
So what we'll do is we'll switch back over to the slides, and I think we'll cover off a little more on under the hood. So it's all very well knowing kind of the basic setup of DPM. The UI, the wizard's quite simple and very easy to set up, but it's quite good to know how this stuff works under the hood and what DPM brings you that you may not necessarily get with other backup and recovery products. So we're going to explain a little more on what the replica is, how that works, and all the details of how the block level copy works. So bear with us as we go through this. There's quite a few little points that you need to pick up on. So the first thing to note is that before backup, the way things work are that we'll have our protected servers. So we're just going to pull out one server here and some volumes on that server to walk you through. So we've got our SQL server, and that SQL server's got multiple volumes on it. And of course, we have multiple databases on that SQL server. And like I said, when you protect a SharePoint database, or sorry, a SharePoint farm, you're protecting the content within that farm, and it will appear automatically in the list and be backed up. The way DPM works is that we actually have something called this DPM filter, or this volume map. And this volume map lives in page pool memory, and it's used to actually keep track or tabs of what blocks are changing on the server. So for every single block of data that exists within these databases, we'll actually create an area in memory where if a write happens, we will switch a bit from a 0 to a 1. And we continually do that until we do another backup. So we know after half an hour or an hour that 25 or 1,000 blocks changed on the disk. And then when we come to do a backup, we only grab the blocks that changed. So that's really important. We're not grabbing all of the database, and we're not grabbing what would be a differential type backup. We're doing incremental. We're grabbing just the individual blocks that have changed. So it's very, very efficient. So let's walk you through this process and how it works. So what we're going to do is we're actually going to focus in on one of those databases in that list. Now let's say we are at 10 o'clock at the start of a synchronization window. What we want to do here is note that we've just created our replica. Our replica has just been created, so we've got a full copy of our DPM replica. And what that DPM replica is, just to be clear, is it's a full copy of all our data on our DPM server. So the way DPM works is it doesn't just do multiple full backups because of what I just said. It always has a full copy of your data stored on DPM. And it's only behind since the last incremental backup occurred. So if you've got a 250 gig content database, you'll have a 250 gig replica of all of that data at, say, 10 o'clock on your DPM server. Then if we were configuring the schedule to say every half an hour, we're going to track those changes and send them over. After that half an hour's passed, we will only send the blocks over that have changed and sync them into the DPM replica. So the DPM replica is as up to date as your full data source, or only as behind as your last backup that you took. Okay? And this process will show you how that works. Now, focusing in, like I said, on that one database, because it's a volume level sync, and this maps quite nicely when we do it like that. Obviously, that database, Content DB1, is made up of blocks on the disk, and we need to monitor those blocks. So for every block that makes up the data, we have this volume bitmap, like I said, and that is used to say, has this block changed, yes or no? It's as simple as it is. So what happens is we do a file write. The blocks on that disk get written to, and a change is made. And what happens then is that in memory, we go and flip a bit from a 0 to a 1. Now, of course, because it's just a 0 to a 1 in memory, it's a very small amount of data that's being stored in memory. We're not copying all of the data that's on disk into memory. We're just saying, it's a map, right? It's an index. We're saying, you need to go and get that data from the disk when you need to do a backup. We then do another file write, some more blocks get written to on disk. So in memory, we flip some bits, and we say, you need to go and get them at some point later on. Same thing happens again, a third change, just so that it really gives you an idea of what's going on at, say, 10:18. And now we're at a point where we're ready to do a synchronization at half past. I already know that no more changes are going to happen. So we write them over to the volume bitmap, we store that data, and we're ready to do that sync. So at 10:30, DPM is configured to do a sync. And the agent on the servers hosting this data is going to send the blocks that have changed over to the DPM server, which we'll walk through in a minute. And this is what we call an express full backup, okay? So the synchronization starts, and we take a VSS snapshot. And this is basically a snapshot, like a point-in-time look or view into the data. And what that basically means is that the database is, or the content in this case, is frozen, and we're able to copy that data out and send it over to our DPM server without corrupting the backup. But it's not frozen in that we can't continue to do I/O on the data. It's frozen in that if something does change, we use something called copy on write. And that means that if, for example, block 12 in this diagram got changed once we're starting to sync data over, we won't send over the changed block. We'll send over the block as it looked when we took the snapshot. And we'll copy out the data on the disk into another place in memory, and we'll overwrite that block, block 12, but we won't send the change because we want to make sure that it was consistent at the time we took the snapshot. So copy on write enables us to make changes on disk still whilst retaining the original data that was on disk when the snapshot was taken. That's very important. So what then happens a couple of seconds later is we will start syncing all of that data over to our DPM server. Those blocks get written. And that might take a few minutes depending on how often you're doing your express fulls. If you do one express full a day, then that volume bitmap is going to have tracked a lot of changes across the disk. If you do 10 a day, you're still sending the total same number of blocks because you're not changing any more data. You're just sending 1/10 of the data every single time, or depending on how much the churn is over those hours, okay? So synchronization starts, and in the meantime, we continue doing file I/O. We continue writing to the disk. Now, in this diagram, you don't see it trying to overwrite a block, But if, for example, block 16 tried to overwrite block 12, what would happen is we'd copy out the data in block 12 to memory, overwrite block 12 with block 16, and when we start sending the blocks over, we'd send over everything on disk plus the value that was in block 16 from memory to the DPM server. That's the way VSS works. Okay? So it's very efficient, and it means we can continue writing to disk and reading from disk whilst we're taking backups, and it will be consistent at the point in time that the backup was started. What then happens is we obviously update the bitmap in memory because we still need to track that change for the next time we take a backup. So we've frozen the blocks, if you like, for the point in time we started that first backup, but any changes after that snapshot, we still need to continually track until our next copy or backup, gets taken and gets sent over to the DPM server. Synchronization ends, so we finish sending all those blocks, a couple of minutes has passed, and the DPM server replica is now up to date, and it is as up to date as the data source, minus those, for example, 5 blocks that have changed since the backup started. Then what happens is we release that snapshot, so we say delete anything in memory that's no longer needed, any copy on write data that's been stored in memory, and reset that volume map. Reset the volume map, but include, obviously, all the blocks that have changed since we took the backup or the backup started. And then the process continues and goes on and on and on until we do another sync and round and round and round. Okay? So that's kind of what happens when we're doing backups. That's kind of how backups go from the agent will communicate and figure out what's going on a disk, store it in memory, and send stuff over. But how is DPM efficient in terms of storing this stuff on the DPM server without duplicating the data? Well, I talked about that replica. The replica's on the right here, and the production data in our SQL database, and these are blocks on the disk, by the way. So for all intents and purposes, imagine this is a single file that's split into multiple blocks on the disk. Now, the original data at 10 o'clock is the same, because we've just done a sync, and nothing's changed since we started doing the sync. So at 10 o'clock, the replica and the production server are absolutely identical. What then happens is we might do a data change, just like you saw in the example just a second ago, on the production server. We flip some bits in memory, of course, but then when the next sync occurs, we're going to send those bits over to the DPM server. So an expressful backup, a backup, occurs at 10:30, and we just send those 2 bits on disk over to the DPM server. What happens is they get written into the DPM replica, and we overwrite the blocks in the DPM replica that's the full live current copy of our production data. Of course, you think to yourself, well, what happens if I want to go back to 10 o'clock? We still keep the data, blocks C and F, but we push them down into somewhere called the DPM recovery point area. And that's where we store the deltas, if you like, of the backups, what's changed from the backup and the previous backup, what's different in the replica versus that recovery point. Same thing happens again. In this case, we change a couple more blocks, K and L get written in, and we send K and L over to the DPM replica. We overwrite A and G, and we move them down into the DPM recovery point area. And this process goes on. Again, M, N, O, P, and Q get written. The data might grow a little bit. We send those blocks over, and we update the DPM replica. So a one-to-one likeness between replica and production with only a small amount of time where the data isn't as up to date. The recovery point area gets updated with the blocks that we change. So what happens if we want to recover back to, say, 11 o'clock? So at 11:30, we know we looked in a certain way, but we want to go back to the 11 o'clock time slot. Well, what DPM will do is it will overwrite the production data with the blocks as they looked at 11 o'clock. So it's going to do something like this. It's going to go KBID and so on, and it knows, because it keeps a record of this, a track of this, that it needs to restore some stuff from the replica and some stuff from the recovery point area. If we want to go back to 10 o'clock, we know, because we did this diagram, right, that at 10 o'clock it was all the orange blocks. So it's going to literally go A, B, C, D, and so on, all the way through, to take us back to as we looked at 10 o'clock. What we're not doing is we're not doing full backups or differentials here. We're not sending across blocks that haven't changed. We're only sending across blocks that are changed. So it's very efficient in the amount of storage it requires. The initial hit of taking that replica and having that full replica might seem like quite a lot, having a 250 gig copy of your data, but one full backup is exactly the same. And we'll talk through this in a while, but if you did a full backup every day for a week, you've got 7 250 gig backups. This, I guarantee you, is going to be a lot less depending on your data churn. We will walk through that. So hopefully that explains a little bit about the internals and what's going on. Let's actually show how recovery works and show you a demo of doing recovery.
Okay, so just to clarify as well, the two areas that Chris was talking about then around the replica and the recovery point area, those are the two things that map back to what we showed you in the disk management area in terms of what actually will be stored on the disks in that DPM storage pool. So hopefully you can make the connection there. Okay, so over to recovering SharePoint data. Let's start with the example of recovering a SharePoint content database. So this first example, assume that you want to take a content database backup that you have, and you want to overwrite an existing content database in your SharePoint environment. Probably fairly rare scenario, hopefully, but how this actually works in DPM, the DPM server will send the database over to the SQL server. It will overwrite the existing database. It will restore over on top of whatever we have there. And what it then does is, and you'll see the connection there to the SharePoint server, it will actually make a call to the SharePoint server and refresh our sitemap in SharePoint. So for those of you that aren't aware, in SharePoint, in our configuration database, we have a table called the sitemap. And this tracks a list of all the site collections that exist in our farm. When we overwrite a database, we may be changing the actual list of site collections that is existing in our farm, depending on when that backup was taken, have sites been added or removed between the backup and what's currently in the production set of data. So by DPM making that call to the SharePoint, we can refresh the sitemap and update that list to ensure the sitemap in our configuration database is in sync with what we have in our content databases. So as I mentioned, that's kind of like a rare scenario, hopefully, having to overwrite a database in that manner. A more common scenario may be actually just restoring the database to a file share. In this example, it kind of looks like we've just restored the database there to another server in our farm, but we could be restoring that database anywhere. It doesn't even have to be a SQL server. We're literally just restoring the file to a file share somewhere on our network. And this may be useful in scenarios where you want to get a copy of your database, carry out some troubleshooting in a testing environment, for example. Okay, so moving on to sites, lists, and items, and how the whole item-level recovery piece works. Due to the unattached content database recovery capabilities that we have in SharePoint 2010 and 2013, we can actually leverage this in DPM. So the first example that we look at here, if we want to recover a particular item from a point in time back to SharePoint, what we can do is restore the database to a SQL server that actually hosted that item that we want to recover. Note that, again, although this looks like we're restoring this database to a database server in our SharePoint farm, that could be the case, but we really could be restoring this database to any SQL server. Because we can use the unattached content database recovery capability, we don't actually need to attach the database to SharePoint. SharePoint can speak to this database as long as it has access to it. We don't need to register that database with SharePoint. So then, to extract the item we need, what SharePoint will do is use the Content Migration API to actually create a content migration package. So it's exporting that item from the content database that we've restored in SQL without the database being attached in SharePoint. SharePoint can then import that package to the relevant content database. So if you're restoring the item back to its original location, it will place it back in the content database where the site collection that wants to host that item lives. There we go. Click. Okay. So in fact, that's the way DPM 2010 did things. And we still have that method there for fallback in DPM 2012, but it's not actually the default option, the default approach that we take. So the problem with that approach is, if in the example of restoring an item, that item may be, say, 10 or 100 kilobytes, if the content database that that item exists in is much larger, so say 200 gigabytes, in the previous example, we'd have to restore that entire database, so the 200 gigabytes content database, to a SQL server, which could take some time. So with DPM 2012, when we initialize a recovery, the replica on the DPM server is exposed as a share. We can then, on the SQL server, which is obviously going to be remote, remotely mount the database from this share. The rest of the process is kind of exactly the same at this point. However, when we're actually making the call from SharePoint to create our content migration package, the SQL server is only going to need to retrieve the data that it needs from the DPM server. We no longer have to restore that entire 200 gigabyte database. So you can imagine for recovering a small item, this process is going to be much quicker.
And this is one of the main or the only big changes from a SharePoint perspective in DPM, from DPM 2010 to 2012, for those of you that are wondering. There's a lot of other changes under the hood that make DPM a much better product from a tape, for example, perspective and online backup. But from a SharePoint point of view, this is quite a big one, because restoring those large databases every single time we need an item level restore isn't very efficient. If you do 10 item level restores a day, that could be 10 200 gig databases that are being sent over the wire. This literally is remote attach a database in SQL right into the live DPM shadow copies and pulling the data out back into SQL as a content migration package into the SharePoint farm. Was there a question? Can you put it into the mic if you can? Or sorry.
Was just wondering how it works with blobs, if we were storing anything onto a blob.
So when you say blobs, you mean with like remote blob RBS,
Yep.
for example?
Yep.
Yeah. So it's a good question. We were kind of hoping that was going to come up rather than covering on a slide. Basically, the way RBS works in this scenario is that if we're using FileStream and the FileStream provider, so the built-in SQL one, DPM will actually protect that data and everything just works transparently. Nothing else to consider there. If you're using any other RBS provider other than FileStream, DPM isn't going to protect that, because DPM doesn't know how that works. And as with every backup and recovery tool, it's down to the vendor and them to provide some sort of sync or way of doing that. It's just the inherent nature of RBS. It's not really a limitation of DPM. It's just an RBS issue that you need to have that vendor support or a way of grabbing that data and keeping them in sync. So it's not the magic bullet for RBS, if that was what you were looking for, I'm afraid. I don't really know if there's that many tools, other than the scenario where if the vendor supplies an RBS provider, often their backup and recovery tool quite clearly works with it, i.e. DPM with FileStream, right? Hopefully that kind of answers the question. Yes for FileStream, no for any others. Okay.
Okay, so there's one other approach that we also need to consider, which you may be familiar with if you have used previous versions of DPM with SharePoint. The previous approach that we've just discussed only applies when we're restoring content that is from the same SharePoint build that we're currently running production in. So this means if you've taken a backup before applying, say, a cumulative update to SharePoint or a service pack, and you've incremented the build number of your SharePoint farm and all the content databases that live there, in order to actually restore content that may be at previous build, we need to get that content to the same build. In SharePoint, content migration API that we use here in DPM and we've discussed is not possible to actually take content from a prior build or any different build and restore that to a higher build in SharePoint. SharePoint doesn't allow that. So the way we work around this in DPM is to actually introduce a recovery put farm. So this is a SharePoint farm that you set up and should be running at the same build level as your production SharePoint farm. So what happens in this scenario is we take the database that hosts the item that we want to restore, we attach it to the recovery farm. So this is now a SharePoint attach. So we've restored it to a SQL server, it gets attached to SharePoint, and on attach it's also upgraded. It's the way SharePoint works when you're doing a version-to-version upgrade. We'll get into the details around the differences there with the build-to-build upgrade, but DPM will actually take care of that and attach the database to SharePoint, upgrade the database so the schema is now at the same level as your production SharePoint environment. Once we've done that, the process is pretty much the same again. So we create the content migration package this time in our recovery farm. We send it over to the SharePoint server that is in production. That server then will import it over into the relevant content database and put it where it needs to be.
So you're all probably wondering, well, doesn't that mean that that operation is a lot longer because we're not having that remote mount? And we're also doing an upgrade now. Yes, it is. You're doing a full restore of that 200 gig database, and now you're upgrading that database to pull out a 10 KB file. That's not a DPM issue. That's just the way the SharePoint API works. DPM is just using the APIs that it's got available to it from SharePoint, the content migration ones, and because SharePoint doesn't support that difference between versions of import and export, as Sam said, this is the only way to really work around that. And in fact, if you were to do this manually, if you took DPM out of the picture completely, and you took a SQL-based backup of your database before you installed SP1, for example, then you tried to restore, do unattached export, import, it would fail because you can't do that unless you upgrade the schema first. That is just an inherent limitation of the way SharePoint works. So you just need to be aware of that. It's quite unlikely that that's going to be a scenario, and obviously once you've installed a service pack, it may be that if a user says, I need that file back from 2 weeks ago, it's going to be more and more likely around the time of a service pack, but it's only going to be for a short period of time that you would hope that users will want files going back from 2-3 weeks before. Of course, working with my customer, and I'm sure most people in the audience know, that a user will delete a file and they'll want it back from the last 15 years at some point at the worst, most inconvenient time possible. So just be aware that that might take a little bit longer. And in fact, the SLA would have to factor the fact that once you've moved between a service pack, the restores are going to take a significant amount of time longer. Okay.
Okay, so we'll move over to the demo and show you what recovery looks like in DPM. We flick over. So back over onto our demo machine. We're in the DPM console where we left off. What I'm going to do is navigate into the recovery area. So within the recovery area, there's two ways that we can perform recovery. Focusing now on item level recovery, so thinking about restoring a specific item, a list, or a site. There's two ways we can do this. You'll see here on the left-hand side that we have browse, and we also have search. So we can actually browse through a calendar to a specific recovery point and then drill down into, for example, a content database. Within that, we can see all of our site collections, which is a recoverable item itself. We can go into a site collection, see all the lists and so on, and find a specific item. Alternatively, if I know what item I want to recover and I want to see what recovery points are available for that specific item, I can search for it. So if I know the site name, I can do a search. If I know the document name, I can do the search for that. So let's flick over to our SharePoint site that we have here. So this is just a standard team site that we've set up for the purpose of this demo. We have a document library. Within this document library, we've got a few items, a couple of pictures, a text file. And what I'm going to do is delete an item here. So I'm going to delete this About Us picture. So let me just do that. Am I sure? So it's going to be sent over to the recycle bin. And just so that everyone is absolutely sure that DPM is carrying out this recovery as we've described and not using the SharePoint recycle bin, I'm going to go over to the recycle bin and delete it from there too. So you can see that the item's here in the end user recycle bin. Definitely sure that I want to get rid of that. Go over to the site collection recycle bin, delete it from there too. How end users manage to do this and then realize they need it again, I have no idea.
6 clicks to do a delete, and they want it back straight after they've done that 6
Okay,
click.
so that item's gone. Everyone happy with that? It's removed from SharePoint. No coming back, unless of course you have DPM. So let's flick over to the DPM DPM console. What I'll do here is search for the item, search for About Us. Right. Actually, it might take me a little while finding it that way. I'm going to just cheat and go to a specific recovery point. Might be a little easier. So if I go to a recovery point, I'll go to Monday this week, 12th of November. Choose the content database, DPM demo site collection, and down to the shared documents library. You can see there's a few items in here, and I've got the About Us PNG file there, the picture. So I'm going to right-click that and click on Recover. So SharePoint gives me a quick summary of what I'm asking it to do. It actually highlights the source version too. So this is where you will know if you actually are going to be using that recovery farm when DPM performs the recovery. Presuming you know the build of your production farm, of course. If I go through the wizard, I have a few options here. I can either recover to the original site, so back to that DPM demo site in this case, or I could actually recover it to, an alternate site. So choose a different site collection. I'll just recover it to the original this time around. Again, you do have the option here now to specify whether or not you want to use that recovery farm or not. So if you know that you're at a different build, you would need to obviously choose that option.
DPM doesn't figure it out for you that you're at a different build. It will just throw an error saying that it's not possible because the versions mismatch once you've tried to do that. So although that would be nice, it doesn't do that. It's not a major issue because you'll see the error in the UI once you've made that mistake.
Okay, so what we're now specifying is the SQL instance where we're going to mount this database. So you can see that's what it's asking me for, a temporary database. Database server. I'm obviously going to select my SQL box that's just here in my environment, and the instance there. I'll now specify the location on that server as to where the database will be restored to.
So this seems a bit weird. We're saying we're going to restore a database to here. We're not actually doing the restore of a database. We're specifying the location here because the way that DPM works in this version 2012 is that it will actually try to use that what we call optimized inline recovery, where it will do the remote mount from a DPM replica area and the recovery point area to the server listed at the top. But if for some reason it can't, it will fail back to doing a restore to the file location that you specify there. So you always have to specify that location, but it doesn't necessarily use that. The way to tell whether it's used that or not will be that it will take 5 seconds to do the restore versus, say, 15 minutes or hours if it's a massive database that you haven't controlled with your governance and so on.
Okay, so the next stage here is asking me to specify a staging location on my SharePoint server. So this is a location on the SharePoint server to store that content migration package temporarily that's created for the item that we're actually recovering. So on my SharePoint server here, I'll drive down into a pre-created folder once that spins up. So C drive recovery will do. Hit OK there. Click on next. Now we have a few options. For any of you that have used the export and import migration API in SharePoint before, you'll be familiar that you can configure it to keep its original security settings of a particular object that you are exporting, for example, or you can actually specify that you just want it to use the destination security settings. I'll keep the default setting here. There's a few other options on this page too that we don't need to worry about for now for the purpose of this demo. Okay, so then summary comes up. I can see exactly what point in time I'm recovering from, the source, the actual recovery item. Oh, sorry. Windows Server 2012. Okay, and the recovery item. If I hover over that, I get the full URL as to where we're recovering to. Okay, so I'll click Recover. That job's in progress. I can close this window now. And if I shoot over to the monitoring area, I can see here that there's a couple of jobs in progress. You can see one of these is running on the SQL server, and one is running on the SharePoint server. So the first job here on the SQL server, that's the restore of the database. And then the job on the SharePoint server is the SharePoint export and import task. However, the type is, they have the same type listed here because it's relating to the same overall activity.
So you will see an additional step if it does do a restore. So again, when Sam says restore there, it's actually a mount, if you like, a mount into SQL Server remotely in this case. But if it was doing that full restore because it had to fail back to that old approach, it would take a little bit longer and you'd see an extra task in there. And the reason why you see those 3 tasks is, in this case, is it's one, to do the mount into SQL. Second one is the DPM agent on the SharePoint server doing the export. The third one is the DPM agent on the SQL server deleting the database, tidying up, or deleting the mount point to the database that's remote, tidying up afterwards, okay? So the DPM will tidy up after itself.
Okay, so that restore has completed, according to this, successfully. So if we head back over to SharePoint, back to the DPM demo site, and we can see it in there. Just to make it a little clearer, you can see that our items in here successfully restored about a minute ago, obviously by DPM. There we have it.
So those of you that have done a restore of an individual item manually in the past before will appreciate that that is a hell of a lot quicker than attempting to do it with a manual restore of a database and export manually and so on and so forth. DPM is really automating all of this stuff for you and giving you all that extra capability around searching and figuring out where the content is, okay? So, slides, yeah. So that's it for the demos. We're going to walk through a few more slides. We didn't spend a massive amount of time going through demos, but if you look at the DPM console, you'll see that that is pretty much all there is to it. It's a very simple console and UI. It's simple for a specific reason. I just want to walk you through very quickly a couple of more slides that pull out details around why DPM is more efficient than other backup and recovery methods. First of all, though, let's just focus on a few little caveats or a few little things that you need to know about recovering SharePoint data. Now, the RBS point is one that's come up that we've mentioned them. Another one is that you do need that recovery farm in some cases, and we spoke about that in length, so hopefully that's clear as to why. There is one key point, though, is that recovery farm, which can just be a virtualized box. It can be a box that's running somewhere that you don't care about, pre-production, whatever, as long as it's the same version. That does need to have a web application that's named the DPM recovery web application in that exact way. The reason for that is that the agent on that box needs the agent as well. When DPM does the recovery of a database to there, it will automatically attempt to mount it to that web application. That name is hard-coded in with the way the agent works. Once it's been upgraded, it will do the export like Sam showed you, push it over to the SharePoint server, and then the agent on the live production server will re-import it. The product group were probably trying to be funny. The web application has to be called that. It also has to be on port 911. The next one is the full farm restore requires the same farm configuration. So we didn't show you the whole full farm restore stuff. It's quite a lot to show in a demo, and it doesn't really make that much sense. But if you did want to restore those configuration database and the associated database with central admin, you can do that. And the reason you can do that is because those snapshots that we talked about, that volume shadow copy services, what it does is it snaps those databases at the exact same point in time. This isn't like going to the SQL console and clicking backup, backup, backup isn't transactionally consistent, right? You can't guarantee transactional consistency by doing that. VSS can, and that's why it is supported and only ever supported to do config DB restore using VSS. Other third-party products can use VSS. DPM is a third-party product, if you like, to SharePoint that's using VSS. But if a vendor or DPM or someone is using VSS, then you can do that. It is supported. The same configuration point that I'm talking about here basically means that when you do that, though, you can't restore the config DB to a new farm with new server names and everything else. You're restoring a config DB. That contains farm details. It contains server names. So you have to use it to do a full restore to the same servers in your farm. You have to have the same web front end that you're restoring to. So in the disaster scenario, you would spin up a web front end with the same name, deploy a DPM agent to it. You would then initiate a restore, which would push the data down. Obviously, it'd have to be the same SQL instance as well. Okay, so there is a few little things to be aware of there, but it can do full farm restores in that scenario. The final point is there are some caveats with the export and import API. Again, this isn't a DPM limitation. It does the best with the APIs that are given to it. And the export and import API for SharePoint does not pull out a few things that you may want. For example, if you were doing restore of a site collection, which is the exact same process that Sam showed you for a document, you just choose site collection in the UI there. When it creates that content migration package, it won't include some things in there. And it won't actually include things like content in the recycle bin, because the content migration API doesn't do that. It won't include details of in-flight workflows. And there's a few other little caveats with the content migration API that get dropped off. You don't really lose any data that's arguably that important, but for example, the state of the workflow could be quite important depending on the application, so I wouldn't want to kind of make that overarching statement. But just be aware of the caveats of the export and import API, and if you're using the unattached recovery method manually without DPM, it's the same set of caveats. Okay? So finally, let's just very quickly walk through a DPM versus SQL Server backup type scenario. First point here is that we've got 4 databases that are 250 gigabytes in size. And these are content databases that are 100, 50, 40, and 60 gigabytes respectively. And if we assume a 70% compression, we're using SQL compression or third-party compression during backup, and we do full backups, we'll get something that looks like this. Now, 70% is quite kind for this scenario. With blobs, it's quite likely that the compression you're going to get is going to be much lower, around 40, and with the latest Office doc formats, which are kind of in a fairly compressed format already, it's going to be even less. But making it generous for the SQL side here really shows the numbers off from DPM. So 75 gig per backup. Every full backup that you take, if that's full daily, is going to be this size. Of course, most of you are probably thinking, well, I'll do fulls weekly and then diffs. Well, you're still getting a 75 gig backup every week, and then your first diff is going to be quite small, but your second diff contains all the stuff in the first one plus the next days, and the diffs get bigger and bigger. So you do have that fall, and you do get worse and worse as you do more and more diffs. So it's still going to be a significant amount more than the DPM approach that I'm going to talk about now. So for 2 weeks, you're going to need a 1 terabyte storage area to store those backups, assuming, again, you're doing fulls every time. Now, if we speak about DPM, same scenario, same databases, we need that 250 gig replica to start with that we spoke about. So we always need that. So let's say that's part of our backup. We need that as the replica. And that will obviously grow as our data grows, but let's just say it's fixed at 250 gig for the moment. We then make some changes. And for this scenario, the changes are actually, we're removing this amount of data and re-adding it. We're not growing the replica, let's just say. But we are making this amount of change a day. 10% of churn across those databases would be 10, 5, 4, and 6 gig respectively. Now, that's quite a generous amount of churn for a content database. If your content databases are changing that much, you've got quite a busy and active farm. So it's actually probably more likely to be 5%, which we'll speak about in a second. Now, that's going to give us 25 gig per day times 13 days, because we're only sending over the block level differences. So we're only sending over the churn, the transaction log, the changes that have happened, if you like. So we end up having a 375 gig DPM recovery point area. And like I said in the diagram of the blocks, we've got 250 gig DPM replica, 375 gig recovery point area. We need both to merge blocks and send them back to live. So they're both classed as our backup data. That will give us 625 gig if we do 2 weeks of backups. So we're already nearly half the amount if we're doing SQL fulls. But let's just say that's the same as if we were doing diffs. Let's just say that was very similar. Well, if we did 5% change, which is probably much more realistic, and in some scenarios, if you're just using SharePoint to do archiving or there's not as much change happening in certain databases, obviously the size of your backups is going to be very small, very, very small. DPM is not going to be doing very much at all after that first initial replica. With that scenario, we're actually talking about 168 gig of recovery point areas, and that's going to give us under half a terabyte for 2 weeks. So we're already less than half of what we need for SQL server backups. If we scale these numbers up from 250 gig and we scale up the amount of time, that's a significant saving in backup cost in terms of the amount of storage that we need. And of course, if we start using the cloud to store some of this stuff, again, you could potentially save costs and operational overhead. From a perspective of difference here, we could store with 1 terabyte's worth of storage 2 months of DPM backups versus 2 weeks of SQL Server fulls. That gives you an idea of the scale of the benefit of using DPM for that reason alone, let alone some of the item level type stuff, cloud backups that we spoke about. So that brings us to an end of the session, and hopefully that gave you a good broad overview of what DPM gives you as an IT pro or anyone that's managing this type of stuff. And you can see the benefits of what DPM gives with an open and honest view of kind of some of the caveats that you need to be aware of. Obviously, things like inline recovery, full farm backup, cloud-based backup, all make DPM quite a compelling story. Equally, though, it might not be the perfect solution for you, so I would recommend you evaluate it and think about it in terms of the full stack that it can back up and restore. If you've got any questions, we'll be around for a couple of minutes. We might have to take them outside. We're just about on time, but feel free to drop us an email if it's not that pressing. Thank you very much.